All right, today 11.6 we are going to be using properties of chords in a circle. So we're still talking about chords. We will also be talking about arcs some more. So for our warm-ups, if the arc of a circle is 100 degrees, what does the inscribed angle measure? Angel? It would be 50. So if we look at a diagram, you can always draw yourself a little picture if it helps. Inscribe an angle in here. Label that the arc was 100 degrees. The angle is how much of the arc? Half of the arc. So the angle would be 50 degrees. All right, it will also help if we draw a picture for number 2. If the radius of a circle is 5 inches and the shaded area of the pie is 60 degrees, find the arc length. This is something we haven't done in a little bit. So I'm going to draw a picture up here to help us out with it. Okay, we have a circle. We've got a radius of 5 inches. So it's saying that the shaded part of it, we'll say that's the shaded part, is 60 degrees. And we are asked to find the arc length. So this is a 60-degree angle in there. The radius is 5 inches. Does anybody remember how we did this? Angel? Okay, we had to set up a proportion, which is 2 fractions set equal to each other. One of those fractions was the measure of our central angle. What's our angle? 60 degrees. Over how many degrees? 360. Good.
Over 5.
Not just 5. 2 times pi times 5. Thank you, Jordan. 2 pi r, yes. So 2 pi r, or 2 times pi times 5 in this case, represents the circumference of the whole circle. 360 represents the degrees of the whole circle. We are trying to find just the length, or just the piece of the circumference formed by this angle. So that's x, that's what we don't know. And 60 degrees is the measure of that angle forming the arc. Now if you want to, we can simplify 60 over 360 on our next step. So the zeros would divide off. 6 over 36 simplifies to be 1/6. If you don't simplify that fraction, it's fine. You're just going to have bigger numbers to deal with. It's not a huge deal. Equals to x over 2 times 5 is 10. So this would be 10 pi. How are we going to solve for x now? What do we got to do? Cross multiply. 10 pi times 1 is 10 pi. 6 times x is 6x. Last thing to do? Divide by 6. So then in your calculator, you would put 10 times pi equals divided by 6 equals. And that would give you x. What do we get? 5.23. That sounds about right. Inches. Should it be squared? No, because we were not finding area. This is just a length. The first theorem states if 2 chords intersect inside a circle, then the measure of each angle formed is 1/2 the sum. What does sum mean? Addition, plus 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Now in words, that sounds a bit confusing, but after you get it copied down, we'll go through the picture and statement part of it down at the bottom. It makes a little bit more sense. So the whole idea is 1/2 the sum of the measures of the arcs. The rest of it gets a little wordy, so if we have a picture, it makes a little bit more sense. So we know if we're focusing first on angle 1, if I were to trace that angle just like we'd been doing on the inscribed angles that we just reviewed in 11.5, then the first arc that I'm interested in is the one that kind of completes that pie piece. So that would be arc AB. So that's why for measure angle 1, you see measure AB back here. I would recommend just adding little arcs over all of those to make sure we know we're talking about those arcs. And then also the arc intercepted by the angle and its vertical angle. So really what that means is the arc on the complete opposite side of the circle from it. So in this case, that would be the arc CD or DC. So those are the two arcs that we're interested in if we're focusing on angle 1. So we add those together and take 1/2 of it. So to take 1/2 of something, we can either multiply it by 1/2 or we could divide it by 2. So we'd add those two arcs together, divide by 2. Same idea if I take away those marks. If I wanted to focus instead on angle 2, so I trace over angle 2, I connect that arc to finish off that pie piece. That's my first arc, AD, which I've got back here. The other arc I'm interested in is the one completely opposite from it. So that's going to be the arc between B and C, which is why that's the other arc that they included. Add them together, divide by 2. That's going to give you the measure of angle 2. Questions about this theorem before we practice it with actual values, numbers? Okay. The other thing I want to point out real quick while we're looking at this is what would angles 1 and 2 add up to if we were to just add those angles together?
3.
No.
4.
How do we measure angles? What unit measures angles? Degrees. How many degrees would I have if I added angles 1 and 2 together?
180.
180. So keep that in mind. If I were to find angle 1, I should be able to know angle 2 by taking 180 minus angle 1. That relationship is still true because they are still a linear pair, meaning they're supplementary.
So if you take 180 minus angle 1, that would be the sum of that angle?
That would give you angle 2. Angle 1 plus angle 2 would have to add up to 180. So that's a helpful trick to remember on these problems sometimes. All right, let's, I guess, nope, 2 at a time. All right. So if I'm interested in this angle here in the middle, notice I don't really know where the center is here. They did not mark a center, so I cannot assume that that angle happens in the very center or not. So in order to find the measure of that angle that they marked with an X, it's going to be equal to 1/2 times the sum of the two angles, one of which is intercepted by that angle, which would be what? What arc is intercepted by that angle? If you need to, you can trace over it. What arc is intercepted by the angle that we traced? X is the angle. What is it? 170. So that's the one of the angles that I need. Plus, what angle is completely opposite from it? 60. So those are the two angles that, or two arcs that I need to add together to find that angle. I believe you are correct. So we are going to end up taking half of 230. Half of 230 is 115. So x would equal 115.
You just put degrees or not?
No, they put the degree symbol by the x. They just told us to find x. If you put it, it's not wrong. It's fine. Okay, on number 2, we have to be a little bit careful because this time they gave us the angle. So if we wanted to write ourselves a little note at the top, on these ones, angle is equal to 1/2 arc plus arc. They gave us the angle this time. So we are plugging 68 degrees in for the angle. So 68 equals 1/2 times, what is one of the arcs that I'm interested in? 38, and the other one is x. So the one that angle creates, that was the x. The one totally opposite from it was the 38. Now we've got two options when we solve one set up like this where the x is not already alone. What's one option? No, we can't subtract anything yet. We could distribute the 1/2, or we could multiply both sides by 2. Which one do you want to do? I would recommend multiplying both sides by 2 if you remember to do that. If you do the distributive property, that's fine. You're just going to have a fraction with your x. It's not a big deal. You'll just have to deal with it later. I'd rather get rid of it right away. So I would rather multiply both sides by 2 so that my 1/2 goes away right away. And I'm left with 38 plus x. What is 2 times 68? 136. Now what do I need to do to get x alone? Subtract the 38. And we get x equals 98. Yes, they put the degree by the x, so I'm not so worried about it. But if you do put the degree symbol, I will not mark it wrong. We'll just edit that real quick. So this should be marked with an x instead of a 1, but I believe that is the angle that we are supposed to be finding. So we'll mark it with x degrees. Did they give us the arcs that we want for that angle? No. They did not give us the arc from that angle. They did not give us the arc that's opposite of that angle. So there are a couple ways we can go about this.
Would it just be supplementary to?
So yes, so the angle we want is supplementary to these other angles here. So if I marked this angle with a y degrees, for example, x and y have to be supplementary. So if we can find angle y because they gave us those arcs that we would need, then all we have to do is subtract y from 180 to get the angle for x, which is our end goal. Does that make sense? Well, let's see. So y is our angle is equal to 1/2 times what, Julian?
1/2 times, times 80 plus 72.
Good.
And then you add those together. It's 152.
152, I agree.
And then y is equal to 76.
Y is equal to 76. Very good. Are we all okay with finding y? Okay. Then to find x, we are going to subtract. So x is going to be 180 minus 76, which is 104. All right, go ahead and try number 4. 4 should be easier than number 3. We'll go over it together in just a minute. All right, how did we set up number 4? Good. X equals 1/2 times 63 plus 99. 63 plus 99 gives me 162. Half of that is 81. We all get 81? Those of us that took the time to do it? Good. Ready to move on? All right, number 5 is going to be similar to which problem? 3. 5 is going to be similar to number 3 because they did not give us the arcs that we wanted. Julian?
It would be 1 equals 1/2 times 100 plus 70.
Good.
That would be 174.
Good.
And it would be y equals 87.
Beautiful. So once we find y, we know that x and y have to be supplementary. Thank you. So to find x, we need to subtract from 180. What do we get for x? 93. Beautiful. All right. Number 6 is going to be similar to which problem we've already done? Number 2. Very good. So they gave us the angle on the inside already. So we have to plug that in on the left. So it's going to start off with 74 equals, what's going on the other side? 1/2. Then the 124. What symbol am I missing? Plus x. Good. Now you have 2 options. Again, you can distribute if that's what you're more comfortable with. I like to get rid of my fraction right away. So what am I going to do? Multiply by 2 on both sides so that my fraction is gone. 2 times 74 is 148 equals 124 plus x. Last step. Good. We subtract the 124. X is equal to 24. Our next theorem says that if 2 chords intersect inside a circle, then the product of the lengths of the segments of one chord equal the products of the lengths of the segments of the other chord. Again, gets really wordy, but when we're able to draw on a picture, it's not that bad. So we'll talk about the picture in just a moment. So all those words really just mean that if we've got 2 chords inside our circle, we can see that the chords break each other up into 4 smaller segments. Do you see that? They all meet here at this point E. So if you take the 2 lengths of one chord, so they started off with EA and then also EB, and they multiplied those 2 lengths together. That's going to be equal to, or the same number you get, when you multiply the 2 pieces of the other chord together. So in this case, that would be EC times ED. So instead of thinking about those as 2 big segments, we think about it as being broken up into 4 little segments. We're just multiplying their lengths together. They would be equal to each other. Questions about it before we practice using it? Okay. We are solving for x again. So you can kind of choose which segment piece you want to start with, but we have to make sure that we can identify these as 4 separate segments. So somebody give me one segment length they want to start with. Julian? 14. Okay, so we start with 14, so that is this segment here, this big long one. That's going to get multiplied by which other segment?
6.
The 6, because that's the one that completes that chord. We would set that equal to, now on the other side, we're going to multiply the 2 pieces of the other chord, which would be what? 12 and x. Do we have questions about how we set this up? Okay, the theorems are wordy, but when we put it into practice, it's not usually all that bad. 14 times 6 gives us 84 equals 12x. To solve for x, divide by 12. X is 7. Would I put a degree measure on 7? No, these are segments, not angles. So if you were to put a degree measure now, you're risking losing some points. That's just a careless thing we should not be doing. All right, on number 8, somebody give me a segment they want to start with. 10, sure.
Maybe,
Martez.
so is it best to start with the numbers and not the eights?
It's up to you. It doesn't really matter as long as you're following a straight line. So which one has to go with the 10?
8.
The 8. So we would have 10 times 8 equals 16 times x. If you wanted to do the 16 and the x first, that's fine. That's why I say just pick one to start with and go from there. 10 times 8 is 80. To get x alone, divide by 16. What do we get for x? 5. Questions, concerns? Ready to move on? Believe we've got one more. Here it comes. All right.
This one's confusing. Is it a decimal?
It's possible. Let's set it up and see.
No, it isn't.
Let's start with one segment. What do you want to start with? 10 gets multiplied to the 18. 10 times 18. What's going on the other side? 22 times x. 10 times 18. 180 equals 22x. Last step. Divide by 22. What do we get for x?
8.18181818.
Oh, okay.
No, it doesn't repeat. It ends with a 2.
Well, your calculator says it ends with a 2, but it probably is a repeating 1/8. So if you wanted to put, what is it, 8.18? If you put 8.18, I'm fine with that. If you were to put 8.2, probably be fine with it. If you want to put your repeating bar, that is wonderful. If you just reduce the fraction, fine with that also. I'll be a little bit lenient. If you just put 8, however, I'm marking it wrong. Okay, this is not rounding up to a whole number.